Hi team, welcome to Wiggins Maths. In this video we're going to be looking at how to sketch parametric equations on a Cartesian plane. So let's go straight for it. Okay, so here we have a parametric equation, x in terms of t, y in terms of t, and a constraint on t. Now when we've sketched graphs in the past, we may have been drawing a table of values and then using that to plot coordinates. We do exactly the same with parametric equations. The only difference is we need to decide what our values of t are going to be. And the best way of doing this is by splitting this into many parts. Now, the more practice you get at this, you may be able to do this in fewer parts, but essentially it's until you can see what the graph looks like. So for this one, I have chosen to split it up into quarter pies. And then we will type our value of t into each of these two, and then it will generate a set of coordinates. So when you substitute in pi over 4 into x, you get negative 1.89 and you get 1.41. Generally speaking, 2 decimal places will do. When we sketch it, obviously it's a sketch, so it's going to be an approximate, whereabouts is 1.41, for example. Pi over 2, negative 4 and 2. 3 pi over 4, negative 6.12 and 1.41. Pi is negative 7 and 0. 5 pi over 4 is negative 6.12 and negative 1.41. 3 pi over 2 is negative 4 and negative 2. 7 pi over 4 is negative 1.89 and negative 1.41, and for 2 pi it is negative 1 and it is 0. So now what we've got to do is we've got to decide how we're going to draw our set of axes. Now obviously the scale is going to be a little bit awkward, so we need to be quite sensible with this. So we have a look at x. It's always negative for x, so that's going to help me decide how I'm going to draw my set of axes. Okay, and for y we've got positive and negative values, so I'm going to do something like this. Then in terms of the scale, I think it's, we've got negative 2, negative 7 is the smallest value, and we've got a negative. Okay, so I think we're probably going in ones. All right, seems pretty sensible. Try and get it as evenly spaced as you possibly can. I know it's not going to be perfect in this video, but that is the joys of technology for you. So we've got negative 1, negative 2, and so on. Grab yourselves a cup of tea while I do this. Okay. In essence, we're trying to get a feel for what this graph is going to look like. And then for the y-axis, it's between 2 and negative 2. So I'm going to go up in 0.5s. Now, enough that it's going to be a little bit easier for me to actually plot these points. Obviously, when you do this on paper, you'll use a ruler and measure it out properly so that it is reasonably to scale. Nearly there now. Okay, so the next thing we've got to do is we've got to actually plot these coordinates. So negative 1.89 and 1.41, so about here and about here. It's not far off. Negative 4 and 2 should be a little easier. Negative 6 and 1.41, so negative 6 and 1.41, so it's going to be level with this one. Negative 7 and 0 is down here. And can you start to see what shape it's going to make? Negative 6.1 and negative 1.4 is about there. And negative 4 and negative 2 is down here. Negative 1.9 and negative 1.4, again level with this one, so about there. And then negative 1, 0. So that gives us an indication of what shape it's going to make, and I'm going to do my very best here to draw something that is reasonable. Obviously yours is going to be a lot neater than this, but it's created some form of circular object, maybe a slight ellipse, but that is the graph that we get when sketching this. Okay, second example, this time algebraic functions rather than trigonometric. Constraint on t, sensible, I'm going to go up in ones. So here I'm going to get 16, 9, 4, 1, 0. 1, 4, 9, and 16. And then here again, 1 decimal place, 2 decimal places, whatever is most sensible in the context of the question. So negative 1.6, negative 0.2, 0, and then we're going to get the positive values, 5.4 and 12.8. Okay, again, we need to make a sensible decision on our axes. So our x-axis, it's always positive, and our y-axis, we've got positive and negative, so something like that. Again, 16 is the largest, 0 is the smallest. Maybe go up in twos. So 2, 4, 6, 8, 10, 12, 14, and 16. That's not too bad. Okay, so let's label that in there. And then our y-axis again, so from negative, say 13 to positive 13. Again, I'm going to go for twos, but obviously my scale is going to be slightly different. So 2, 4, 6, 8, 10, 12, and 14, and the same on the positive scale. So 2, 4, 6, 8, 10, 12, 14. Okay, so let's see what happens when we sketch it this time. So 0, 0. We've got 4, negative 1.6, and 4, 1.6. We've also got 1, negative 0.2, and 1, positive 0.2. So that's going to go about there and about there. 4, 1.6, so just below 2, so there, and it's going to be there. And then we've got 9, 5.4, and 9, negative 9.4, so 9 and 2, 4, 5 and a bit. So about there, and then 2, 4, 5 and a bit. So it's just generally trying to get the shape of the graph. And 16 and 12.8, so 12 is up here. And then same here. And then this time it's going to be a slightly different looking curve, just to try and get some form of idea as to what's going on here. And generally you get the marks for your table of values and for the shape of the graph. So slightly different looking graph this time, and that's what parametric equations can do. They can produce some really, really weird and wonderful wonderful graphs. Okie dokie, so that's it for this video. Remember, just by watching this video doesn't mean you'll instantly be able to do it. Practice will make you so much better at this, and you'll be able to spot patterns more quickly. And of course, amateurs call it genius, masters call it practice.